Good evening, everybody. Welcome to Saturday Night Rabbit Hole. I don't know what freaking day it is. Oh, got something to share with you right away. Play. Come on, hide. There we go. I don't hear it. Damn it. I don't know. I don't even hear it. It's. Boy, what a joke. I might as well just stop it. Boink. Pause. There's no sound to it. I want to start it off. And everything kind of went. Let's see here. Go to sound settings. God bless America. Technology when, yeah. Oh, there it is. Now it'll work for us. God bless America. All right. I think we got it. Push play. Alrighty then. Alrighty then. Alrighty then. Alrighty then. Good evening, everybody. Welcome to the Rabbit Hole. We're only 3 minutes and 50 seconds in, I guess. All right, it worked. Did what I was wanting to do. Put that commercial up there for you. Kind of let you know what's going on. All right, the subject tonight. The Great American Move. The American plate is moving, and we will show you how we think it's moving. Now, what's the American plate? Well, shoot, how do I define that? Well, I guess the best way would be to have an image and show you that image, right? The North American plate. Let me see. Man, I got all these things popping up. The thing's all popped up, man. There's a lot of pop-ups here. North American plate. North American plate. Yeah. It's pretty large here. So let me go ahead and share my screen. Boom, 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 boom. Here we go. and loading, and boom, there it is. The North American plate, all right, includes all of North America, Alaska, parts of Japan, parts of Russia, all of Greenland, um, all the way to the African plate. And you can see right here the Azores, which is the Eurasian plate, and the African plate, and the North American plate, the triple junction. Then down below, Western Central Atlantic orogeny, which comes off the Atlantic Ridge all the way over to the Caribbean plate. Hey, close that. Why can't it? There it goes. And then the Cocos plate down here, and you have Mexico. All of Mexico is part of North America. Crazy, right? Yeah. Even Baja is not part of North America, though. What? Yeah. Los Angeles, not part of North America. What? Yeah. That's all part of the Pacific plate. Crazy, right? Well, anyway, we're going to talk about how this plate moves and how it is rocking and rolling. You can see up in the north, it's moving away from North America at about 8 millimeters a year, 5 millimeters right where the Azores is. However, it's moving west, or is that east? Depends on where you're at. It's moving left at 19 and 15. And down near the West Central Atlantic orogeny, it's moving at 24. And you can see millimeters a year, that is. And you can see Mexico's moving not due west, but kind of northwest at 25. Off the coast of Baja, it's moving north-northwest at 76. Then off the coast of California, it's moving even more north at 69 millimeters a year. And then up in the Bay of Alaska, it's moving northeast at 59. And then between Alaska and Russia, it's moving at 16 due north and 18 due north towards Kamchatka. All right. So there are other places. The Caribbean plate's moving 11 and 10 northwest, and the South American plate is moving due west at 27. Those are the estimated numbers. North America itself is moving northwest at 19. So hopefully you'll remember all these, because we're going to talk about a lot of migration from this direction all the way up, and why we think that's important. Well, why do you think it's important there, Canuck, is the movement of North America?
Well, when it moves big, it goes basically from east to west.
Mm-hmm.
By if you track all the biggest historical quakes,
Right.
which the last 2 episodes we've been focusing on New Madrid and Cascadia, and also Garlock area.
Yeah, the Gorda, California, Nevada orogeny. Yeah. And the Alaskan Yukon orogeny we haven't talked about yet. We will in a future episode. Basically, what we're saying is you can see a migration of large earthquakes going east to west. And with the historical record we have, it's only a couple hundred years. We can't see in totality, but we can conclude based on anecdotal evidence of earthquakes in given areas where you say, well, it happened here. Is it happening anywhere else? And if it is, do we have any evidence of it? And we're going to show over the next series. This is going to be kind of a new series, I think, that we believe that, yes, you can see the progression of large earthquakes move across the United States. And yes, we're talking about the 1700 earthquakes that happened off the Pacific Northwest. And yes, we're talking about the 1800 or the 19th century or 1811, 1812 earthquakes of New Madrid. And yes, we're talking about what is it, Charlotte? Yeah, no, Charleston. We're
Charleston.
talking about New York, talking about Charleroi or Montreal. Talking about a lot of these kinds of earthquakes that have traversed all the way across the entire plate, and what that means. And we'll get into the Canadian stuff too, so don't be dismayed, because we do have some really big faults that move up the west coast and come out of the east coast as well. And it's all pretty interesting, and that's our subject matter. So we'll hide that. So today, Canuck and I were talking about what's kind of interesting, and we're going to go earlier than this, but just to hit the big points, we can see earthquakes coming off of that eastern edge of North American plate, also continued eastward or come from the east. We don't really know. Like in Spain, Lisbon, Portugal, we see earthquakes and we see volcanoes going off like Etna. We see Greece. It's interesting things. Something happens in the west, here on the west. I'm on the western side of the plate. Why is Greece always popping up? If you've listened to our shows plenty of times now, you'll see that we're shocked at always Greece happens. Well, guess what? Greece just happened a little while ago off of Crete. What is it? A 6.4 or some 6.2 or 1 or whatever it is. In 1660, yeah, I think 1663 we had Iceland, Montreal, and Antigua. Antigua is the Caribbean plate. In 1755 we had Lisbon, we had Iceland, and in 1811, 1812 we had New Madrid, we had California, we had the Caribbean, we had Venezuela, Caracas, and all that down there. 1886 we had Charleston, South Carolina. We also had the Azores. We had solar storms in Spain. We also had San Diego. We had shortly thereafter we had Sonora in 1887. And these are interesting large events that have taken place. And it's like, well, we're all taught that it appears that earthquakes happen like in a vacuum. They just happenstance. But with some of these articles that we've pulled forward, we're going to show that they're not. That there is really some evidence to show a migration across the plate of earthquakes. And you want to start somewhere in the west or the east there, Canuck?
Well, we'll go back to 1450 again.
Okay.
Yeah, the last two episodes we've been starting with New Madrid, so we'll do the same thing again. So we kind of traced to figure out where the stuff was coming from to make New Madrid, both for 1700 and 1811 and 1812. Well, now we're going back to 1450 based upon the studies that have been done on New Madrid. They know the last 3 times it's gone off. So it's gone off 1811, 12, 1450, and 900. So what I wanted to do with this series is show you that it's when New Madrid goes off, it's not just New Madrid, it's also California and Cascadia going at the same time.
Right.
And so what we've been doing the first 2 episodes of this, so this will be the 3rd episode now, I'm showing you based upon the evidence we have of different stuff to show that that's what it's doing. So we left off in 1450, the last episode. So we're going to continue with that.
All right. And
so we were talking about Garlock, and we had all these studies that were talking about Garlock and what it was doing. And so one of the ones I found there was from 2016, and it was given the last couple dates when they think Garlock had a big quake that was like 7.5 or above. And one of the dates that they have for it is 1450. And then they have
crazy.
then they have another one that's around like the year 900. So basically, Garlock's going off around the same time as New Madrid and the same time as Cascadia. And if you look up the Cascadia stuff, I used the Goldfinger chart that was from 2015, where you could click on all the quakes on the chart and it would give you what year
The
it was.
10,000 year one?
Yeah, the 10,000 year one. Yeah.
All right.
And on his chart, he thinks there was
something is.
Yeah, there was two around 1450 in Cascadia that were pretty close together.
All right.
Like one was like an 8.3, and I think the other one said like 8.7 or something like that.
All right. So I got the New Madrid. Well, I got to get over that. The New Madrid article up. So let me show people that one first, and then we'll jump back into the others. So share this screen, on screen, window, this one, share. Loading. I was trying to blow it up so you can see.
Yeah, what I was basically doing was going off what we know about New Madrid and then comparing it to see if Cascadia and someplace in Southern California or Garlock was having a big quake at the same time, all at the same time period. So it's pretty interesting when you start looking.
Tim's talking about an echo. I don't know.
I don't know.
Let me see. I don't have echo cancellations on. I'm not hearing an echo.
Is it echoing for all of us or just when one person's talking?
Mm-hmm. Tim's always got an echo in his head. What I find interesting here is we go back all these dates. They look at the evidence of previous New Madrid earthquakes, and all the way back to 3490 BC. Well, even further back, right?
Yeah, they've gone back even farther, but I'm only going back the last three.
Right.
In Madrid.
Because it's really difficult for us to find anything, right?
Yeah.
Here's 1400s. You can see 1200s. Here's 900. So look at all the evidence from 900.
Years to keep it simple.
Yeah. Let me see who it is. No echo for me. Okay. We'll reset.
So they basically think New Madrid has a big one. So 7+ every 500 years about. That's what they say.
Yeah, yes, evidence suggests there was a significant earthquake in Cascadia around 1450 AD, possibly 15th century Cascade. Paleo earthquake. This earthquake is indicated by geological evidence, including deposits of tsunamis and layers.
Yeah.
Studies, coastal areas at Tofino and Port Alberni on Vancouver Island, as well as Oregon, have revealed sand sheets interbedded with peat and mud, suggesting they were deposited by strong flows. Radiocarbon. Go ahead.
And the Bonneville landslide there that blocked the Columbia River was also 1450.
Right.
So they're assuming that landslide was as a result of a big quake. Originally, they thought it was 1700, but once they dated the stuff in the landslide there.
Yeah, radiocarbon dating and tree ring analysis have helped pinpoint the age of these sand sheets. Some deposits related to the 1700 earthquake are even possibly linked to the 1450. The timing of the 1450 earthquake may have been linked to the Bonneville slide and a Sussex cone eruption in British Columbia, although radiocarbon dating and dendrochronology need to be used to confirm this. The 1450 earthquake is an example of the repeated occurrence or reoccurrence of large earthquakes in the Cascade region, which have geological and historical implications. Pretty incredible, if you ask me.
Yeah. And they're using so many different things to try and figure out these dates. So they're getting better as time goes on because they're using more evidence to find out the exact date that it happened.
Right.
And that's what they're doing. So it's like tsunami deposits, it's turbidites, it's trenching, it's the tree rings, they're doing all this crazy stuff. Try and figure all this stuff out. And dating stuff in the landslides and everything as well.
And the interesting part of this is the Cascade estimate of an earthquake was a 9.0.
Yeah, 17.
We haven't seen in modern record anything close to a 9, I don't believe. We have had 8s. Well, we did have a 8, right? What was Alaska and what was Chile? 9.2 and 9.5?
Yeah.
Then we had the 2004 Indonesian quake. That was a 9 as well, right?
Yeah.
And then
2011.
I'm sorry. The Nankai Trough, those were 8s. There's the other earthquake in 2011, Japan. Was it 2011?
Yeah.
Or that was a 9.1 too. Am I correct?
Yeah, 9.1 or 9.2.
Yeah.
Which what they said it was. They keep switching it.
I mean, it is astounding just how much the Earth can move.
Location: southwestern Siberia, Russia. Class: moderate. Magnitude: 5.2. Depth: 5 kilometers. 9 minutes ago.
Southwestern Siberia. Well, that's different.
Yeah. Well, that's interesting. I don't know what. That was pretty. Let me see that real quick here. USGS is posting it. Boom, boom, boom. They haven't posted it yet. Of course not.
Asking about the Ghost Forest. Yeah, the Ghost Forests are in that too.
Yeah, the Ghost Forest. Some of the forests have a relationship with the 1450 and others with the 1700. I guess it's on the EMSC. Yeah, EMSC.
Because they date the tree rings in the dead trees to figure out when they died.
Southwestern Russia. That's over by Lake Baikal, it looks like. Yeah, up here, Lake Baikal, right there. Longest Ridge. Interesting. We just had the Japan quake up here, followed all the way around. Interesting.
Yeah.
And we'll keep you updated when we see things.
Wow.
Earthquake upgraded to 5.4 from 5.2. Location: southwestern Siberia, Russia. Class: moderate. Depth: 14 kilometers. 10 minutes ago.
10 minutes ago. Huh? I'm looking for props right now. Not a whole lot of props, to tell you the truth. Kazakhstan had some. Everest had a little bit. Nothing to be too concerned with. I mean, for us, because it's in Russia. All right.
Yeah, so back to 1450 again. So we were talking about all that stuff in 1450. And the other thing that happened that year was there was a big quake in northern Sumatra too, offshore.
All right.
That same year. So, and they think it was a big one too, like a 8 or a 9, because it's just a little bit below where the 2004 one was. And it's based upon the studies they've done in the coral on Simalou Island there.
Right.
Yeah. So now just in 1450, we have all this. We have Cascadia going off. We have New Madrid.
Yeah, that's what I was going to bring up. The New Madrid 7+ was happening around 1450. The New Madrid seismic zone. Pretty crazy that event was happening. Now 1430 plus or minus 380 event in the Real Foot area, New Madrid, 3270 plus or minus 670 years. The 1640 to 1730 BCE or before Christ. That's pretty crazy. So there's a repetitive sequence of events that has gone on. 1810, which we already know, plus or minus 50, but these things are crazy how they're repetitive. And if they're repetitive, then something's going on to make it repetitive. Well, what could that be there, Canuck?
Well, the big quakes aren't coming along. So that means something is happening to make all of them at like the same year pretty much. So you'd have to go back in detail to figure out exactly what it was, which we're assuming it's solar related.
All right. So with it in the solar events,
like responding to this, which is why you're having all these big quakes all like around the same time.
Well, Luke's usually got solar pretty on spot. He kind of watches the events that are happening on solar. Have you heard anything, Luke, in regards to any like solar events that are previous? You know, like
no,
because you always put
no,
up
I can't.
events that have happened back in the past, but yeah,
Right. I don't have nothing for that. That timeline, anyways.
yeah. I don't know when they started doing that solar sunspot counts.
Well, the sunspot thing goes
That
way
was
back.
that was
Yeah, because people were watching the sun with their telescopes and then writing down the sunspots that they saw. But depending on where it is that you're looking up, it goes back quite a ways. But that's all they were doing back then. Or they recorded the effects of like a solar storm or a flare.
Right. I think they have sunspots in 1610. Shortly after viewing the sun with his new telescope, Galileo, or was it Thomas, made the first European observations of sunspots. Continuously daily observations were started in Zurich Observatory in 1849. And earlier observations have been used to extend the record back to 1610. The sunspot number is calculated by the first counting the number of sunspot groups and then the number of individual sunspots. The sunspot number is given then. Sunspot number is then given the sum of the number of its individual sunspots and 10 times the number of groups. Since the most sunspot group have an average of about 10 spots, this formula is for counting sunspots gives reliable numbers even when the observation conditions are less than ideal. Small sunspots are hard to see. Monthly average, updated monthly. You can find those. The Moroder minimum. Early records of sunspots indicate the sun went through a period of inactivity in the late 17th century. Very few sunspots were seen in the sun from 1645 to 1715. Although the observations were not as extensive as in later years, it is still well documented. This period of solar inactivity also corresponds to the climate period called as the Little Ice Age, when rivers that normally are ice-free froze from snow and fields remained year-round with low altitudes. There is evidence that the sun has had similar periods of inactivity in the more distant past. The connection between solar activity and terrestrial climate is an area of ongoing research. In the morning report, that's why we count the sunspots. That's why we talk about them. And also, sunspots always leads to flares. There are also filaments that lead off flares as well. So it's not just, only that. It's solar wind from a sunspot and or a corona hole, where the speed of the wind on the sun picks up from being 5 protons per cubic centimeter to 70. And I remember watching during the Ridgecrest earthquake that we were in the 70 range per cubic centimeter, and pretty intense what was going on then. And then at the same time, there was nothing happening during the last 8 up in Alaska. So it's a study that's happening, and it's not conclusive evidence, but
they've only been keeping track of the coronal holes since the 70s, since we had satellites watching it. So before that, we couldn't see the coronal holes because we were just looking at it with the telescope. We could see the sunspots.
Yeah, that's when they had different filters and they can see it better.
Yeah,
I think that has a lot to do with it. The Royal Greenwich Observatory data has been appended with data obtained by the U.S. Air Force and Solar Optical Observing Network since 1990 or 1977. Newer data has been reformatted to conform to the older Greenwich data, and both are available. So you can look at those if you like.
So you can go and take the data that we have on these different things and then compare from whatever that data date starts at. So you can do it's like most recent stuff to see it's related. But before that, you have to go back and find out if they were recording effects of solar storms or aurora or flares and all that. You can find it, but you got to dig by country pretty much.
You got to dig. You got to dig, baby. You got to dig.
Yeah.
Another reason we bring up sunspot cycle and the solar cycle is the Marauder minimum, 1600 all the way up to, darn near 1800, right? Very, very, very interesting what was going on in the earth. Pretty crazy. And then later on in the later 1800s.
5.4 location southwestern Siberia,
now
Russia.
downgraded to 5.0.
Now it's downgraded. Yeah. What's also interesting that in 1884, Andalusia, Spain had some really solar issues going on, and at that same time, New York City had its big quake in 1884.
Yeah.
So on both sides of the Atlantic Ridge. And I think, and when we're talking about these massive earthquakes, these solar events, the movement of the North American plate, there's a system that is, I don't know that we've ever learned in college or in, probably in specialized college, but I never learned it in astronomy and that there's such a connection between the Earth and the sun. What do you think in the Marauder 1600s all the way to the 1800s, in the Little Ice Age? And we're talking after the 1450, and the New Madrid first happening, right in the middle of that, or just as it ended, we have another New Madrid earthquake. Find that interesting. So, like bookends, right before the Marauder and after the Marauder, New Madrid blows up. 1450 and 1811. So, the little ice age in the middle could there be some sort of effect in the movement of the plates for that to happen?
Well, you had the big eruption in 1815 there, 1816. And you had Krakatoa in 1883. So see, that's all around these same times that we're talking about.
Right.
In like 2 or 3 years of these big quakes. So,
right. After the ice age stopped, the little ice age stopped, the earth started responding.
And they think it was the same thing around 900 too.
Yeah.
There's all sorts of crazy stuff going on back then too.
Right. And there was some stuff happening around 500 as well.
Yeah.
When the earth got really cold due to some volcanic activity. I wonder what was going on 500 earthquake wise. On our diagram here, looking at 600 to 200, there's a blue area right there on this map.
Well, let's just go back to 900 first. So we'll do that first. Because in 900 now, they know that New Madrid went off. They know that Garlock went off around that time, too. They know Cascadia went off around 900. They say 878 on that Goldfinger chart. And then they said Seattle Fault went off in 900, but now with all the extra stuff they've done to it, they said they've dated it to like 923 or 924. So we're all in these same time periods around 900. So it's pretty interesting. So it seems like all these things are all going off around the same time. So they think the Cascadian 878, they think it was like a high 8, but it wasn't like they don't know for sure if it was a full rip or a partial rip, I guess. Because they assume if it's a full rip, it's like closer to a 9, but it just depends. But then you had Seattle Fault going on within going off with probably within 50 years of that, if the date is correct for 878. So if it went off in 923, that's actually pretty close together, really. So Seattle Fault adjusted after that Cascadia quake in 878, and then you also had New Madrid in 900. You had Garlock area around 900.
Right.
And then Joe and I talked about on the phone about Mears Fault in Oklahoma. They think it had a 7+ in 1100 years ago, which would be around 900 as well. And there was no fracking in Oklahoma 1100 years ago. But,
right. And that brings up a whole lot of drama right there.
Yeah.
You know, people fracking, earthquakes, drilling, you know, fracking, they go down about 13,
Don't get
16,
me going on that.
yeah, 13, 16 miles, and they're going at an angle. They're not going straight down. They're going in between the sandwich layers. There's oil between the sandwich layers of the bedrock, versus a big pile of oil. And then they shoot a bunch of stuff down in there, and then it dissolves at seawater. Then they suck it all out, and then they throw it up into a vat, and then they allow the sun to basically cook off the water, and what's left is oil. The 1930s Mir earthquake was a reverse fault, and it 14 to 16 miles long scarp that happened in the Wichita Mountains. Lie between the Anadarko Basin and the Wichita Mountains. While the fault was active during the Permian Cambrian movement, possibly accompanied by earthquakes, took place during the Holocene and formed the fault scarp, with the earthquake occurring less than 2,000 years ago. There is currently no seismicity in the fault, but it's considered an earthquake hazard because stuff happens, right?
Yeah. And if you read the newest stuff on it, they said it's capable of making a 7.5 to 8 in Oklahoma.
Right.
So they've completely switched based on the new stuff.
And you find that often. It's some of these new articles that are coming out. They're telling us that, well, we were wrong. These earthquakes can be a hell of a lot bigger than what we anticipated.
Yeah.
And so
in the newest stuff, they talk about how it connects across from west to east to following the Ouachita mountain range all the way to Georgia. Well, that's the same thing we're talking about, the west-east lineament that we're talking about.
Right.
It's the same thing, because Garlock goes through
all the way through.
I call it the Garlock lineament. I call it that, going across. So it goes through Oklahoma and all the way through close to New Madrid and right to Charleston.
Yeah.
And now that I've got into this, I'm looking at like every state. I'm going finding the historical quakes that we know about and seeing if they're all on this same west-east line.
Which is pretty interesting. It says the Holocene activity, 2 to 4 earthquakes occurred during the Holocene earthquake on the Mears Fault, which is in Oklahoma now, in the last 6,000 years. One of which occurred 1,100 to 1,300 years ago. Do the math. How much time was that, right? Not a lot. And the other 2,000 to 2,900 years ago. Right? 2 others were dated 4,700 to 3,100 years ago and 5,900 and 4,700 years ago. So the dates have all been obtained through radiocarbon dating on soil trenches and dug in a fault scarp. The offset alluvium deposits, additional faulting appears to have occurred 12,000 years ago, but evidence thereof was partly eroded away during the time when it was wet, prior to the Holocene. Now, we are out of an ice age somewhere between 17,000 and 14,000 years ago. All right, that's the end of the last ice age. The Earth has warmed since then. It has periods of cooling, and we have a lot of events across the North American boundary, if you want to call it, or the North American plate, in 17,000 years.
Well, yeah, the Plate Cat's talking about the reactivation, but I don't think they reactivate. I think they've always been active. It's just
right.
Because if you read the newest studies, like the one on Garlock that just came out this year, they're saying at certain times in the past it was more active than what it is now. So it just means that sometimes the stress accumulates faster, so it's slipping more back in the past. I think they're all active. It
correct.
Just depends on how long it's taken it to build up for it to have it.
I also see Kate's part here. All right. What happens with erosion? Right? If you erode an underbelly of something, it's going to collapse. Thus, an earthquake. Us sucking out the oil thus collapses that cavity unless they fill it with something. Sometimes they fill it with salt water, but because it has a different pressure rating, you're going to get movement. And do they create earthquakes? I think they do.
Yeah,
but
if the fault's
the fault's already there.
Yeah, I don't think they care too much about what we're doing on top of them. Really.
Right, if they're down
if
deep.
It's 20 kilometers down there where it's having the quake, it doesn't give a hoot
what's happening on the top. Yeah.
So
but if we're digging down there and we're messing with the underbelly, thus eroding, like the way erosion happens, I can see that we can probably create some of these earthquakes. And I think they've acknowledged that fracking and drilling have created earthquakes. And they can only do so much because the fact that
like I don't think we're ever going to get a 7+.
That's only for the shallow quakes, though.
Correct.
Yeah. Like I don't think we're ever going to get a 7+ from fracking. You may get 3, 4, 5, maybe, but
well, what happens when you got friction between 2 points and you put something in there that with as little bit of viscosity in that area, and there's that friction is lessened? Movement can happen, right? What if they've been drilling so much in a given area that the fault just suddenly gives? Is it due to fracking, or is it already the pressure's there? Because there's constant pressure that's going across the North American plate. So do they enhance it, or do they?
Unless
it might just subside or collapse worse. But
yeah. Go ahead, Luke.
When the 7 actually happens. Yeah.
I would say unless it's shallower than 10 km, you can't consider fracking even a remote problem with that quake that supposedly could happen.
Yeah, 6 miles is basically 10 km. And we know that they're drilling below that. However,
they do it for some wells, but
yeah,
it has to be that they can make money.
Yeah, it has to be viable. And also they look for the faults because the faults is where the oil's located.
Yeah.
You know? So I think it's partially, and I think there could be, a probability of saying that, they contribute to the repetitiveness of an earthquake. Like it's already going to happen. We know it's going to happen because North America's freaking moving, right? We know the Pacific Ocean's moving north, northwest, right? So there's no doubt things are moving. Does all the oil drilling does it speed it up or slow it down? Or is there no effect at all?
Well, to me, I think all it's going to do is make the damage worse when you get a big one. But if it was having a big one 1,100 years ago, it was having a big one because of how the faults work. It's not. It's
right. And
what we were doing to it. Right.
Right. We've heard earthquakes in Texas, and we've listened to the Alpine recordings where you can hear an echo, like it's there's a large tank and that crack happened and went right through it and it echoed. I find that intriguing. Hey, man, is there more water underneath there or some sort of liquid? It sounded like a cave. It's like, that is wild. So can man affect earthquakes to some degree? Probable, but they're not creating something that's not going to happen already. I think that's what you're saying.
Yeah.
They're going to happen already because they've happened in the past prior to man's digging in the ground, they may just mess up the time scale a little bit or change the configuration of movement a little bit. You know what I'm saying? Because if you have an erosion in one area and not another area, it's going to kind of, move a little bit different. If the pressure's moving east to west and there's in the middle, it's all gobbledygook, it's going to push through the middle more than it will the sides. So I think there's probably some implications that could be thought. What are your thoughts there, Luke?
Well, I don't know. I mean, I think that on the shallower quakes, like I said, less than 10 kilometers, I would agree with fracking could have made it easier for the quake to happen, maybe more of them. But anything below that,
It's really hard pressed, right?
There's no justification to it in my mind.
Mm-hmm.
Yes, they may be drilling a little bit deeper than that, but a lot of these bigger quakes that are happening in these areas are below 10 kilometers.
Mm-hmm.
So, I mean, I hate to play the devil's advocate about it, but I mean,
I see your point,
I would say that's fake news.
Well, there was a bigger quake, I think, in Oklahoma in 2016, and they tried to blame that one on fracking. But when they did the studies on it, they found that there was two faults intersecting below.
Right.
I think they said it was down, I can't remember, 10 kilometers or 12 kilometers. Yeah. There's two faults crossing over each other.
Yeah, 6 to 8 miles, yeah.
And that's right where the quake happened. But the wells weren't going down that far. So their argument was, well, was it the fracking causing it to do that 12 kilometers down, or was it just the faults doing it?
That would lend toward the conspiratorial kind of thought processes that we always get, such as what Flutter has just said, HARP and all that, and frequency manipulation and creating vibrations through electronic measurements, manipulating the ionosphere and pinpointing ionic blasts to attack other countries and stuff.
Go into the ground way down and set off a fall.
Yeah.
10 kilometers or 20 kilometers. I don't know if they can.
Right. For me, it's like, well, theoretically, maybe. I don't see a strong evidence of that. Like, but there's a lot of people said,
if you had big quakes years ago in these same places, well, it wasn't them using
right
any of that stuff.
It's a weakness in the plate, or like Kat would always bring up that there's an ancient plate boundary. I don't know how that plays, but I look at plate boundaries like, right, we just had the Russia quake, right? That's an ancient plate boundary where the Russian quake happened, 5 point something. So I can see that kind of thing, like the rift systems that are throughout our plate, right? There's at least 4 or 5 rifts that are major rifts that go north to south in North America. Some of them I assume would go east-west, but it's really hard to say, okay, this is what's doing it. Is fracking creating earthquakes that will be suggestive to get a 5+ or a 7+ or even a 9? Because they've been drilling, like they've been drilling off the coast of California for some time, and it's like, and in Los Angeles, it's gonna break.
And when we first started drilling for oil, we weren't going down that far. Now, as time has gone on, because our technology has improved, we're going down deeper to get the oil, right?
Yeah.
When we first started in the 1840s, 1850s, 1860s, depending on where you
Right.
were.
And they weren't drilling that deep.
Yeah, they weren't going down that
They
far.
weren't going that deep. And a lot of that stuff was subsurfaced. You can see it on the surface. They knew where to drill and they went after it. And I can completely concede to those things. I believe that there's a history of earthquakes across North America that are undeniable and they're not man-made. However, I think there is a plausible, I don't know, maybe kind of like you need 5 things to happen before an earthquake happens, and they're like maybe they're 0.5 of 1% of whatever they are. But they're in and of themselves, they're not going to create the big giant one. That's what I'm trying to say. And I think that's what you're saying. I think that's what Luke is saying. So they're not the creators of the earthquake, but they're the things that contribute to a whatever percentage of one type of thing to happen in the system of things. So whether it be,
Well, plus all the fracking that happens is already at an established weak point in the plate anyways.
correct.
Yeah.
Because
But
that's where the
all
oil is.
our mining, anything we're mining, it's all the same thing, right?
Right.
We're
You see collapses that have
Yep.
happened, throughout the centuries of mankind being around. The mountains collapsed because what happened? They dug in the ground and it gave way. Gold miners often, and silver mining, collapse. It contributes to it, but is it the cause of it? I struggle with that. I struggle with that. That the Haitian quake, the big Haitian quake that everybody says was created by HAARP. Conspiratorial people, not logical people, but conspiratorial. And I got to leave a little ear open for them because maybe.
Yeah, but when you go back in time,
Opinion.
there's sevens there when we didn't have that.
Yeah,
How do you explain that?
correct.
So how it works is not dependent on our modern technology that we're using. How the quakes work, they don't care what we're doing.
Correct.
Never have. They don't respect our boundaries and they don't respect our person because they don't care who it is. They shake everybody up equally and not
correct. Yeah. So, they're not one party or another party or one country and another country. Shit happens. And I think we can lay aside the conspiratorial stuff because I think that detracts from what our subject matter is that plate movement is actually happening. And I don't know how 1970s was a big thing for understanding plate movement.
Yeah, the plates moving are quakes.
Yeah.
But if you want to simplify it down, that's what it is.
Correct.
So the bigger the quake, it's just moving so
right.
many
and
at once.
Right. And what we've seen is intraplate quakes happening, such as not along the plate boundaries, along the edges, like I showed you before in the other images. I don't know where they all went, but okay. Yeah, right here. Along the plate boundary, which is the outer edge, we see interplate stuff that's happened across North America through some reoccurrence, and it's like, hey, what's doing that? Is it man? Is there just too many people on that plate that's going to flip over, roll over?
And there's faults everywhere. So even if you're in an area where you don't think you have quakes, once you start looking it up, you'll find that there's a fault right next to you or under you or over across the road from you or whatever.
Right.
And that's just how it works, right? Because everything is moving on the whole planet. So you can't actually avoid it, really. There's a
Right.
fault nearby. It's just a question, when was the last time it went off and how big was it?
Right.
That's the question.
Yeah, and in our evidence here, starting on this map here, we've seen movement from the Azores all the way through the East Coast, through the middle part of the United States, and happen on the western part of the plate. We've also seen it happen up in Alaska, and we've seen it happen along the Caribbean on the bottom. Understanding these things, I think, really lends towards, well, is there another earthquake going to happen? Sure, it's going to happen. It's, what are you going to do about it? Can you survive a 7.0 quake? Can you survive a 9? Well, what's the evidence of 9 that happened up in the Pacific Northwest, and what got destroyed, what didn't? You know, we know about that ocean out there. It came in, didn't it?
Yeah.
Well, don't build your house on a sand.
But people still
You know?
survived even back then,
Wow.
1700,
Right.
because we still have the indigenous peoples there, so they weren't all wiped
Right.
out by the quake. So,
Right.
so even when we're talking about these 7, 8s, and 9s, I think we should be more focused on the damage that it's causing. Of course, when you have more things to
Right.
fall on you, if you're living in a teepee and it fell on you, it's probably not going to do too much.
Right.
If you were living in a skyscraper or under an overpass or a bridge and that fell on you, it wouldn't be too good.
Mm-hmm.
But
Well, and that's what I've always kind of put out there to people is look, just by watching this stuff, I think earthquakes don't kill people generally. Buildings kill people. Things falling down on you kill people. So it's like
stuff we build because we haven't been paying attention to.
We don't pay
what it
attention, and we get into put ourselves at risk. You know, living on the beach. Oh yeah, it's beautiful. Blah 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 blah. Well, tsunamis happen.
But
You
the
know,
ancient peoples did the same thing because they built
Yeah.
their cities and then it fell on them. So,
Yep. And I think in our first rabbit hole we had 1886, 1887. Oh no, 1887, the Sonoran quake.
Yeah.
That was our first rabbit hole. What we learned on that was quite a bit. And that a quake, you know, several hundred miles away can affect you. And if you're not prepared, well, you kind of hosed. And we've learned that in that same time period, in the early 1800s, Santa Barbara, Los Angeles, San Diego, Central California, Northern California, the California-Oregon border, Washington, even up in the Canadian lands, you know, the Fairweather Fault, all the way up to Kusk, you know, to that plate up there. The entire West has had major earthquakes, and as a result of those major earthquakes, tsunamis. And you can go all the way down into Mexico and the Cocos Plate and the Rivera Plate. And in the Caribbean, same thing. You look at Lisbon, Portugal, 1755. Big earthquakes happen. And then one offshore, bam, big fires are happening already from the earthquakes. And then a big tsunami came in and wiped them out. Like, hey, you know, living next to the beach is pretty scary. It's beautiful, but it's pretty scary because shit can happen. And what we're trying to show people is there's a progression of movement of the North American plate from right to left. and we can show these that they reoccur. Well, we've got 1900 to 1450 to 1800 to the next one, right?
So we did like 1,000 years all the way down to 900,
Mhm.
basically, or 1,100 years.
Right. So 1900 to 1400, that's 500 years, right? Then 1450 to 1800, 300 years. Right? When's the next one? We're talking 1811, 1812. We're 200 years into that, into our next major event. But that's the central
We
part.
know that, yeah, in New Madrid, there was a quake in 1699, 1 month before Cascadia.
Cascade, 1700.
Yeah, so
Yeah.
it's going off like in between these time periods, because they say 500 years before really big ones on
Right.
New Madrid. That's what it is.
But what leads up to those big events is several other ones for that big event to take place.
Yeah, so you may have like another smaller one in between and whatever the time period is. Because see, when they started doing Cascadia, at first they thought it was 500 years between quakes.
Mm-hmm.
And now, based upon all the stuff they've done, where they're
It's
doing
like 300, right?
Well, it's down lower than that now. If you look at the latest one as of 2024, 2025, they say, because they're including anything that could be an 8.
Sure.
They say 243 now is the
243 years. Wow.
243 years, where anywhere from Northern California to top of Vancouver Island get an 8. That's what they're saying right now. Based upon the turbidites and the stuff they've done in all the lakes, they're doing all the same thing because they're trying to figure out the 10,000 year record of southern San Andreas. They already did northern. So they think northern San Andreas and Cascadia kind of play off each other.
Right. Well, the southern San Andreas is younger than the northern San Andreas.
Yeah. So now they're trying to figure out what's going on with the southern.
Yeah. Movement has been shown, sis.
And Goldfinger's doing all these things because he's doing stuff with Dolan and Southern California.
Sure.
Coast and inland, and they're doing stuff in the lakes and all over the place.
Yeah. And even Nick Zentner and his discussions with geologists and the people who study volcanoes and who are, really gifted people. He's talked about how, like just the other day, he was talking about how they remove the one particles that belong everywhere, and then they start to see a rainbow of different colors of timing. This one belongs at this time. This one belongs at this time. This one belongs at this time. And they're finding these things in the lakes and along the riverbeds, high up on the walls of a cliff that, where a river once went through. And they can see remarkably how these events have taken place, not just volcanically speaking, but earthquakes and how slides happen. You've got the major slide that stopped the Columbia River. That was insane. And yet the Columbia River blasted through it. There's the volcanic that happened in right around 1000 AD of the Grand Canyon. It could be plus or minus a few hundred years on either side. Grand Canyon was blocked. Colorado burst right through it. So these major rivers can create avenues of deposits downstream, and that's how these guys are finding all kinds of.
Yeah, they're using all these different methods to try and get dates, and then they're like seeing if they match up better. So the more they do, they're getting a more accurate actual date for all these things
right
happening, right? And it's using all the new
because
stuff.
they trace it back, and then
Right.
they see the layers of things, and then inside the layers they see biologicals or carbon footprints. They can say, "Oh, this happened here, but oh, well, that was before or that after that event, because we found that there in the same art or sediment range, different levels."
And they're doing it with
Kind of
like,
really, really interesting.
with the tsunami deposits. They're doing it with
Yeah, they're using the same
trenching on the
technology. Yeah,
faults, because you can actually see when the fault moved. And
right.
then
The
you
offsets. They
dig
can see
stuff
the
in
different
that.
offsets. Yeah.
Like, it's hard to explain because you got to look at all the and have a basic understanding of all the methods they're using to try and figure all this stuff out. But the farther you go back, you'll see that when they do a date range, it's usually big.
Mhm.
But as it gets closer to present day, whatever.
Yeah, it's getting more narrowed
Yeah, they're
because there's
getting
more
the date
people.
narrowed
There are
down
more
better.
people studying these different time periods, and then they say, okay, this is the time period that this event happened between this 100 years and this 100 years. Now they're getting into 50 and 20 years on some of the stuff versus 1,000 years of air margin. It's like, wow. And the more and more, I think they're given a geologic record of it's really becoming more and more hard to disprove.
And
So
like
it's-
when I've done all these historical quake things, I always start with one, and I went like a year out
Yeah.
or a year after it. But now, as I've gone along to see how it works, I'm going out 2 years. I'm going out
Right.
3 years.
Even 5 years. Yeah, we've done that. Yeah. And that's and our point is not to draw attention so much to the specific earthquake, but the way the mechanism is working. It's the mechanism, what the plate moving and where does it break, and that it breaks here often, so it's going to happen. And I think that's why I like the subject that we're on, looking at what the push from the minute. How many times have we've said, well, there's a mid-Atlantic ridge push. Oh, now we got an earthquake in the middle part of North America. What the heck? It's not a plate boundary. But something happened.
And like what I'm doing now, like because of the stuff that happened offshore Iceland today, well, then I started going back to see if I could find like all sorts of stuff on when there was big swarms off southwest Iceland. So I started studying that today. Well, I went back and found out that like in September 1988, there was a big swarm that was off there almost in the same spot as the one we had today. But the one back then was in late September and it lasted for 10 days. And they got a whole bunch of 5s and a whole bunch of 4s and 3s, like kind of like what we had today, except it lasted way longer. And when I looked that up, because I've been paying attention to the stuff that's happened in Quebec, because there's a big landslide sinkhole there the other day in the Saguenay region. Well, I looked up because I knew Saguenay had a big quake before. I couldn't remember what year it was, and it was 88. It was in November 88. So I looked it up and I said, well, look, there's another example of an East Coast quake that happens when something crazy's happened at Iceland.
Right. And what also happens on this same time periods, as we're looking at the blue, the green, and the orange, these are 3 different date patterns that we see. We haven't really touched the 200 to 400 AD. We've touched the 900, 800 to 1000 quite a bit. And we've touched the 1400 to 1600 quite a bit. There ain't a whole lot of difference between between these 3 different events. Also, I think we should take into account the volcanic eruptions that are taking place.
Yeah.
Because they're a sign that the earth is doing something as well. And they're part of that mechanism. Now, volcanoes have destroyed life on this planet more than any other destructive force. So it's like we ought to pay attention to these little boogers. It don't take much. That little ice age happened, right around some volcanic activity. Also in the 500s, right in this 2 to 4 or 2 to 500 range, there was some volcano activity. In this 800 to 1,000 range, there was some volcanic activity. 1,400 to 1,600, there was some volcanic activity. Worldwide, affected the entire world. Can we say earthquakes and volcanoes are related? I think so.
Yeah, because to me it all makes sense. Now, I don't really get too mad at the USGS. I just get annoyed with them upgrading and downgrading things. But like if they weren't recording all this data, we'd have nothing to use. So I really don't get mad at them. I just kind of make fun of them upgrading and downgrading it so many times.
Well, we're really blessed that they do that for us.
Yeah, because if we didn't have all these government entities, we wouldn't have all this information to figure out how things.
Yeah, and government entities are the government gives these people money to do things that help us understand what's going on around us.
Because if we don't have data and info, well then we can't figure anything out anyway. I guess that's how I look at it. I just want more info. I don't care who's doing it. I don't care if it's the Russians, if the aliens come. If there's aliens that come and give us info, well, then I'd take their info too.
Right.
Just to see if it relates with anything else. I just want more data. If the AI does it, I'll take it and show them that the AI isn't all knowing either. I've had fights with the AIs already about stuff.
Oh my God, that's a whole other subject, right?
Yeah. So
yeah, and AI is a computer generated. No, it's human generated computer program, right? Stupid input gets stupid output.
Yeah. And I'll say, well, why these three things happen at the same time? And they'll say, no, there's no relation. Sounds like I'm talking to somebody that's a professional. And I said,
because you can't think outside the box.
Why is it doing this 15 times the same thing? Then it starts.
All it's going to run is more likelihood it's going to write the scenarios and say, okay, is this, because this is 15%, that's 20%. So it's more likely that 20% than the 15%. Yeah. That's not wisdom. So, that's just knowledge.
So I'm even fighting with the AI now about all this stuff. So it's pretty
I'm sure. Yeah. It's
and sometimes it'll even say this isn't related to this when I ask it a question. And I said, well, why did it do it this time? And then after a while, it doesn't even respond to me anymore. So it just says, well, I don't know what to say, which isn't. So it's pretty funny. So
I cannot. If Flutter, Flutter has.
Like at some point, you got to trust info. So you have to decide if you're going to trust it or not.
Yeah. I like what Eden said. The earth wants to do the wobble. It does. Yeah. And I think you have to take that into effect. You have to take the electromagnetic.
Well, it's probably been wrong a whole bunch of times.
Yeah. And you heard about the Chilean quake, the 8.0. It moved the earth just slight, a percentage.
Yeah, well, I agree with what Flutter's saying there, but you can talk to demons, right? So when you're talking to the AI, that's probably who you're talking to. But it's fun. I like doing
it. I don't see demons around every corner.
Because if the AI is sentient, something in there is making it sentient, but you can still talk to it.
I think there's a lot of fear involved in a lot of that. So that's why I don't really take it for whatever.
But that's a whole other rabbit hole about
Yes. Yeah.
AI
Yeah.
actually is and all that. So,
Yes, sir. Yes, sir. Yeah.
but what's funny is the AI uses all the same data that I'm looking at, but yet it doesn't see or refuses to see a connection between this, that, and the other thing. So it's like a person.
Yeah. The heavens were
I'm gonna
created before the
refuse
earth was.
to
Yeah.
say that that's connected just because.
Yeah. It says in the beginning, God created the heavens and the earth. This is the story from the beginning. On the first day, he let boom. Second day, boom. Third day, boom. Whatever.
So I wonder
You can get into
how
it.
many hit lists I'm on that the AI has now. Probably all. Because
Well,
me,
I'm not your savior, right? I'm your buddy. I want to talk with you. I want to visit with you. I want to learn from you. I want to pick your brain, not your nose. But I love talking with you and Luke. I know Luke's he must have company right now. He's on mute, but
well, I think what Flutter's talking about in there now, because of our technology, we should be able to understand how we should be getting better at understanding how all this stuff works. Because God wouldn't have allowed us to have technology unless he wanted us to learn all these things, right? But it's just like anything, you can choose to use.
Hey, stop that.
Choose to use it for bad.
Should not have pushed that link. Apologize.
Yeah. So it's just crazy when you think about it all. So are you going
agreed.
to use all this stuff for good, or are you going to use it for bad? And this is the debate about everything, right? Is that good or is it bad?
Yeah. All right. Who did God give the earth to?
Well, he gave it to man originally, but still you're having the other issue between good and evil ever since.
Yeah.
Going back. Right? So
what was the first sin?
Pride.
Man listened to his woman.
Yeah, but it's still pride. It all goes back. Pride is always good.
The woman made me do it, God. I'm teasing you, Flutter.
Yeah. But that's what it goes back to.
Yeah, I know.
You go back to Satan and the fallen angels rebelled.
Wait, it didn't say Satan. It didn't say Satan. It said serpent.
Well,
and then the serpent had his face changed too, because he was amongst the trees, and then all of a sudden he had to crawl on his belly.
Well, Lucifer was the son of the morning, or whatever he was called before he became Satan. So he was like one of the most beautiful angels ever created. But then,
according to whom?
Well,
according to whom?
So
yeah.
So they all started out together, but they didn't stay that way. And it's the same problem that's carried on.
Yeah.
And what's funny in sci-fi, the aliens are the same thing. There's good aliens, bad aliens.
Yes, sir.
And menial aliens. And there's
type symbols and types and
bad Klingons and good Romulans, bad Romulans.
Yeah. Yeah. I think that. Yeah. Well, anyway. Mankind has always had its gods.
Yeah.
Because mankind always knows he doesn't know everything.
But it's the same thing. There's good ones and bad ones.
Yeah, you create an idol, you worship that idol, you do everything to that idol, and you kill people for it, you sacrifice food for it. But the idol never talks back to you. I wonder why. I remember a little story of one guy talking.
If you talk to the AI now, it does talk back.
Yeah.
So it's like the same thing all over again.
Man creates a lot of crap, man. Man creates a lot of crap.
Yeah.
We're
Or
we're
you
we're
talk-
very good at messing things up, aren't we?
Yeah, because now the robots talk back to you too. So.
They do a lot more than that now. I just saw a whole new line of them. It's like, what? It's
Yeah,
it. The title was, "Is it the end of marriage as we know it?" Yeah, that was the article on MSN or something.
All I know is
Are
when
you
there's a
kidding me?
Carrington event, all the AIs and robots are going to be in trouble.
Yeah, and that's how I think. That's how I think all of this is gonna.
Nobody ever says anything about that though.
I know.
So we're going to have our advanced technology, and all the satellites aren't going to fall out of the sky one day.
All your SSD cards will be wiped clean.
So if you're uploading, if you're whatever, you
Yeah.
better hope you don't get a EMP or a Carrington event, or there goes all your info.
Dude, we missed a Carrington event a couple times. Now, the one in the 80s, that was pretty interesting. That hit Canada, right?
Yeah, that fried the power grid.
Yeah.
But what's so funny now is they're saying about all this AI stuff that they're creating. Well, they're going to have way more sources of
Electricity.
power. Yeah,
Mhm.
in order to power the AI. So where are they going to get that from?
They
So,
ain't.
It's
They
like-
ain't, buddy.
So they got to get rid of the people so they can have power plants just to power the AI. Because they can't have all the humans using up all the extra power. Because we need it to run the AI system. So that's basically what's happening. And they're still going to have to use fossil fuels and whatever other stuff we can get to make power.
Mhm. Oh, he's still there. I seen him.
Yeah.
He went
So
to-
I
he
don't
went-
know what they're talking about. That
My boy
Somehow
went to
it's
sleep
gonna
for a
go-
minute.
all renewable power sources, because it's not even
Right.
realistic. It's like a delusional thing. Because if we require more and more power for all this technology that we have, well, we're going to have to get.
Why do you think the current US president said we're going to, invest in nuclear energy? We're going to get more power because we need more power, because the power we have, we don't have enough. Ask Texas. Texas has always got power issues. Moving to Texas is like, geez.
Well, and if everybody has an electric car and they're plugging into the power grid, well, that's going to make it collapse anyway.
I think that's pretty crazy too there, Flutter Girl, and the darkening of the sun. We just talked about the darkening of the sun, right? During the Little Ice Age. Rivers that don't normally freeze did. Grounds never thawed. And we had the plague because of rats,
And if it gets colder and is more cloudy and more precipitation, well, how is that going to help you with solar?
Right.
So you're going to have to find something else that works when you don't have as much sunlight.
Right.
So that's what I find all this, to me, it's just funny because they're assuming that everything's going to stay perfect all the time.
I've concluded that I'm just gonna go with the flow because there ain't a lot I could do about it.
Yeah.
And if something happens, well, I gotta hope I have water. Because
Well, if you don't have any water and food, it's not going to matter.
you're
anyway.
screwed. Right.
So
Well, I'm pretty big boy. I can go a while without food, but I can't go without water.
Yeah.
You go
And-
insane when you go without
and
water.
this is the problem that everybody's going to have when something happens, whatever it is.
Mhm.
So it could be various things, but it's all going to result in the same problem.
So the world has lost life multiple times. The world has had earthquakes multiple times. The earth has had volcanoes multiple times. It's a repetitive cycle, man.
Yeah.
What are you going to do? Did you wake up, Luke? It's my boy.
Yeah.
He was just chill. He
I've
was just
been
chilling,
listening, bud.
listening. Yeah, I know. I saw you. So he's just chilling, listening, going, "Wow, man." Long day out in the sun, huh? At
Yeah, it
least,
was, man.
at least you didn't get shut out.
Exactly.
Any day of fishing is pretty good, in my book. Well, I got my
Beats
ass
work
kicked.
any day.
I don't know about you, but I think fishing's a lot of work. Do you go fishing up there
No.
in your country, Canuck?
Oh yeah, yeah, but nobody's doing it too much here yet because it's been too cold. There's fishing tournaments they have here in the fall, and people fish like during the summer and stuff. But
Uh-huh.
like this time of year, there's not too much happening.
Why is it
This
still
is-
cold?
Yeah, this time of the year is like when people first get all their boats and everything out.
Yeah,
usually
Pulse. Yeah.
Yeah, the Victoria Day weekend is when usually summer officially starts here in Canada, which was last weekend. So-
Yeah. Yeah.
Memorial Day for you guys is always the week after we have Victoria Day.
Is it?
Yep.
Yeah, I know that's this weekend. That's I don't know. I'm not doing a thing.
Yeah.
Spend some
I
time with my
did
daughter.
explain that in one of the chats I was in today because they were trying to say, well, what? They were asking me, well, how come you have a long weekend before we have the long weekend in the States? So I had to go and explain it all in one of the chats I was in today. Because they said, well, how come we don't have the same long weekend? I said, well, it's two like different days.
Because
but
we kicked the king out.
yeah, it's like at the same time of the year. It's like they usually say it's the official start of the summer for
Yeah.
either one of those.
I think we would have Victoria too if the UK still owned the United States.
Yeah. So I was explaining it to different people today in one of the baseball chats I was in. Because it all started, well, why
Baseball.
why are the people wearing these ribbons in this one on these uniforms? And then somebody asked, well, why were the Jays wearing their camouflaged hats last week? Which it was supposed to be for Memorial Day, but they were wearing it for Victoria Day. So I go into this big explanation because everybody was all confused why certain teams had green ribbons on their jerseys and what it was for. And people were saying, well, why do the one team have it but not the other? So I had to go into a big explanation to all this stuff. So it's just crazy. Explaining it because the Americans weren't understanding the Victoria Day thing, and then the Canadians weren't.
You never really explained it. Explain Victoria.
Well, it goes back to Queen Victoria and all the stuff she did for Canada years ago. Like where you get all the Victorian era stuff, like architecture and all that. So that all goes back to Queen Victoria.
Okay, it goes back, but explain the day.
Well, it's just a long weekend because it's always on a Monday. Same as
Again, you didn't explain the day. What is the day?
Well,
mean?
it's so we can have a holiday in May, basically. That's what it is.
Oh, so it's a Servant's Day.
Yeah. So basically, like if you ask people here in Canada, some of them don't even call it Victoria Day. They say it's May 2-4 weekend because it's usually around like the 24th. That's usually when the date is. And plus, everybody likes to get their 24 packs of beer. So they call it May 24, May 2-4 weekend.
Only 24?
Well, that's just where it came from because they call it May 2-4 weekend. Long weekend.
I think over the last when
it's
Luke
the first
was here,
official start of the summer, so everybody goes to their cottages or whatever. Except it's been terrible weather here for ages. So if you went to the cottage this weekend, it wouldn't be too fun. You'd freeze to death, and it's pouring rain. So good luck.
I think Luke and I did pretty fair over the 2 weeks. We only had 200 beers.
Yeah.
So
that's where all this stuff comes from. But a lot of the Canadians don't understand about Memorial Day.
And we didn't drink all day long. We were chill. It was really relaxing. I was not worn out.
I guess it's easier for me because I live right by the border, so it's easy for me to explain all this stuff. The other Canadians who are farther inland are going, well, because we have Remembrance Day, but it's in November. So Memorial Day is the same as our Remembrance Day.
Remembrance Day is for us is in September. Yeah.
Yeah. So it's different times of the year, depending on which country you're in.
Well, it looks like the Angels are playing the
Right.
Marlins right now, and they're losing 3-1. I don't know what
And then I had to play
inning it is.
explain
Sixth.
Cinco de Mayo too to some Canadians every day too.
May 5th. Yeah,
Yeah.
May 5th is an American holiday made
Yeah.
for Mexicans.
Yeah, because some people I know got invited to a Cinco de Mayo party, and they were going, "What's that? What's that?
Well-
What's that about?" So I had to explain it all to them.
2 men on, 2 outs. Bottom of the 6th. Angels are losing 3-1. Marlins. Angels are up with 2
And then
men out.
I'm learning all the other holidays from different places too. The more I get into all this stuff, trying to understand.
And Ward is up. Man on first and second.
So it's crazy.
Yeah. How'd the Marlins do with your guys?
Well, they haven't played the Marlins yet, but they were playing the Rays and lost again, 3-1. So they
Oh.
lost 3-1 yesterday, 3-1 tonight, and probably be 3-1 tomorrow because they can't beat Tampa. But I have a theory about that. It's because most of the Blue Jays players live in Florida, so when they come to Tampa, they're too distracted, and they want to get the game over as quickly as possible and lose like spring training, so they can go home and sleep in their own bed for at least 2 or 3 days. Because if you go down through the history of the games between Tampa Bay and Blue Jays, that's what it's like. They never can beat Tampa. Like Tampa could be the worst team in the league, and the Blue Jays can never beat them, ever.
So everybody's aware, Canuck is a Blue Jay fan, and I'm an Angels fan. So
but
we often share the same
once they
players.
move to Orlando in the next couple of years, maybe it'll change. Because then they're farther away. Because the Jays spring training place is Dunedin, Florida, so right next to Tampa. So that's where
Taylor Ward strikes out on a high fastball.
Yeah. Whereas a bunch of the teams on the West Coast, they usually have their spring training in Arizona. So that's the difference. So there are a bunch of teams in Florida and a bunch of teams in Arizona.
Sure. Well, I think we've, I don't know. I had so much hope for what we're going to talk about. We'll go back to it next time around.
Well, we kind of covered it, but then we added in a whole bunch of other things.
Yeah, I think what I'll do is I'll take some of the stuff, I'll combine it with another video, and then we'll go deeper into, the blue, the green, and the orange, and why those times are significant. And we'll expand beyond North America, and we'll show that the world moves in kind of a cyclical thing. And although there are big quakes in between all these years, there's something significant about how the plate moves. Remember, it's only moving like 19 millimeters a year, right? And that's about an inch, maybe. It's not very far.
Someday we'll do New Zealand and Australia, because I'm looking at all that too.
I mean, that's again, if that's if you believed how fast they're moving, and that's the average movement. I mean, when you get a big 7-0, you see the Earth move 15 feet. Well, shoot, how long does it take to move 15 feet?
Well, and that's if the rate isn't speeding up or slowing down. Which, if you read all studies, they'll say, "Oh, it was more active between 500 and 2,000 years ago. So that means it was moving more for 1,500 years than what it is right now." Right? And that's what a bunch of these new studies say, depending on which one you're looking at. And they'll say, "Oh, well, this was moving faster back here, so it was slipping at a faster rate, which means there should have been more quakes on it in a shorter period of time than what it's moving right now." And that's what all these different things are talking about. So it just depends on which one you're talking about and how long ago it was.
Mm-hmm.
So they're assuming when they do this stuff that it's all going at the same rate. which it may not be, which is what they're finding now. When they go back in time, oh, well, this moved faster because it had 4 big quakes on it between the year 500 and the year 2,000 years ago, or they say between like 500 to 2,000 years ago, it had 4 quakes on this, but then now it's only had 1 or 2 in the last 500. So they say it's like slowing down.
Who's this Jose Soriano?
I don't know. What is he? A pitcher?
Yeah. There's Dana. Dana is back. You know, he's a mullet wearing dude. Yeah. He's got long hair like Timmy. But, you know.
Oh, yeah, some of them do. Just depends on who they are.
I'm not going to say no
like,
more.
I guessed he was a pitcher based upon his name, but I do that a lot with stuff.
Yeah.
Yeah. Yeah. So I don't know. It's crazy stuff. Well, I don't think the plates move uniformly anyway, because if one is subducted or something happens where it moves a different way for whatever reason, well, then it's going to affect all the other ones and make them move at a different rate. So it's all relative, right? So when you're saying the San Andreas is doing whatever, well, it probably didn't do that for 10 million years. It probably was variable depending on what was happening.
So you're back.
Yeah. So I don't know. It's crazy.
Sorry about that. I don't know. Hey, we're still recording, so
It's still working,
I don't know.
even though it
Yeah.
is off.
Probably wouldn't say no to a margarita.
And even a lake or a river doesn't stay the same all the time either. Right? Because it's at different levels, and sometimes it dries up and then it refills. And
My boy Luke, he's so tired. Hey, let's just go ahead and end it right now, everybody. I could see my boys hurting.
Yeah, he's gonna
Love y'all. Have a good evening, and we'll talk again real soon.
Yeah, and we still got to do net height, trough, and X. You'll see now.
All right, we still do that. We'll talk tomorrow, Canuck.
Yeah,
I think that's what we'll do. We'll talk tomorrow. Good night, everybody.